welcome to this episode of Tips and Techniques video series from Spanner Product Development. I'm Mark Biasotti, and over the next 30 minutes, I'll introduce you to some of my favorite tips and techniques to help you be more productive and create better quality data when using SolidWorks. So whether you're a seasoned SolidWorks user or a beginner, we think you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over 100 clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of SolidWorks Tips and Techniques series.
So with this next tip, we're going to continue with our uses for move face, offset face, move body. And here I have an enclosure that is shelled. It has a upper and lower housing. So I need to create a appearance gap, some tolerancing between these two parts, and then I need to create a offset intersection curve around the top. So let's hide the bottom body, and I'm going to first just take this surface, and using my move face, I'm going to create an appearance gap, a 1 millimeter appearance gap. I'm going to flip it because usually move face will grow faces out from the existing face. So I actually want to go in or subtract 1 millimeter from that. So now that I have that feature, I can go ahead and show my bottom housing again. There's my appearance gap. And by the way, that is a much more robust way to do that than a cut, because a cut assumes that you have some sketch geometry or plane. This is just one feature, one command, one dimension. And unless it grows too far, it'll fail, but it's generally a very robust way to do that. The next thing I need to do is to create some tolerance between this lip that connects the upper and lower housing. So I'm going to use the move face again, and I'm going to select this wall, and I'm going to quickly select it by using select tangency. And what it's done is, even though I have it in section view, I can see it's picked that entire surround. So now I'm going to enter my tolerance, which I think like 0.15 should be a good number. I'm going to reverse it again because I want to take away that wall material. And now I have that tolerance gap. And I've been able to do that rather quickly. So let's go on. We want to then create a intersection curve around the top perimeter of this, and it's not going to be just a linear line, because you can see we have a crown in the front, we have a different crown in the back, we have an angle here. So what I'm going to do is use some of my surfacing tools to do that quickly for me. But I'm going to first take this top face and do a copy of it, which we all know again is offset with 0. Okay, and so let's hide my upper body, and there's that surface body face. And what you might not know is that the move copy bodies not only works for solids, it works for surface bodies. And I just made a surface body here. So now I'm going to move this down 3.5 millimeters, and I'm not going to copy it. I'm going to enter that dimension to be exactly 3.5. And the reason I did that is because I actually don't want to offset concentrically this top area. I just want to move that face down and have a reference that's going to intersect my solid. So now that I have that, in order to get that intersection line, I need to actually kind of extend this out so there is an intersection between this surface body and the outer solid. So a quick way to do that is to use the Untrim tool, and I'm just going to pick this face, and what it does is it extends it out to its original surface feature. And this actually comes through in translation of IGES and STEP too, because the underlying definition of the surface is known. And so what's happening is it's untrimming its boundaries, and it's going before we applied these fillets and rounds to the model. So it's really a much quicker way of doing an extend. You could do extend on the same thing, but you have to pick a lot of edges. And now we can use extend with a much simpler definition. We can extend this even more. And now we have our intersection surface in order to do an intersection. I think I'm going to just use some of my parametrics here, and on this move copy body, I'm going to change it more to be something like 2. And you can see everything nicely updates. And now I can use my intersection tool, which is another tool I use a lot, mostly for reference, but sometimes for modeling. So intersection curve works inside and outside the sketch. We're outside of a sketch, so I'm going to use intersection curve to pick this surface, and then use my bodies filter to pick this body. And with those two selected, now I get a really nice intersection curve there between the two. So that's how to use some of the selection, surface, offset, move copy. So let's continue with our next tip and use this the same model but a little bit more refined. Here we have the enclosure, but now we have a display window. And in order to size this window correctly, we need to actually have the reference of the display itself. And so with this model, there is an area in here where we're going to be having a LCD display, and I've created a plane to where it's going to be placed, and we're going to start a new sketch on that plane. So let's look normal to that. And now we can load a bitmap of the display itself. And again, one of my often used commands on my S key is sketch picture. And I'm going to go find that, that sketch. It's right here. I'm sorry, piece of artwork, not a sketch. And it comes in this default sizing, and it's reverse. So the first thing we need to do is use the mirror tool to get it to its right orientation. And then the second thing that we need to do is to properly size it. Now, because it's a bitmap image, it really has no absolute size. It's whatever the resolution of the image is. And so we want to size it according to our model. And we have this enable scale tool to do that. And the way it works is that you first move the origin location, which is the dot, to a known dimension. And you can see that this artwork was built with a reference dimension here of 2.5 inches. And then we move the opposite end where the arrow is. Let me get off my lasso selection. And we need to move it to the other known. And then once you let up on your mouse, it asks you for what is that known dimension. Now, a lot of you might say, well, you know, I really don't want to place it there because I'm too far zoomed out. Well, if that's the case, you can just say no, exit out, zoom in, and then replace it. Replace the arrow. So I know it's 2.5, so I can enter 2.5 plus the inch increment because we're in a metric model here. So I'm going to go ahead and put that in. And then zoom out. And now we can see that it is properly sized for a model. So we can go ahead and place it to where we need it to be. And then from this, we can reorder it before our window cut and then start to get a little more accurate on our window cut. At this point in the sketch picture, you can actually take this and start to rotate it. You can see that one end is anchored. You can do all kinds of things with it. You can even re-invoke the enable scale tool by unchecking it and rechecking it. So that is the sketch picture. So one of the things in SolidWorks that would be really nice to have, but we don't have it yet, is the ability to move multiple features in the feature manager at one time. Let's say, for instance, in this model that you've already seen, that after we did all of our cleanup, we actually wanted to put the original features before all of our cleanup for some reason. So we know that if we tried to just grab all of these features and then drag them up to right here, only just one feature is going to move. Okay, and it didn't even pick the right one. So I have a workaround, and you probably know this or may not. So a quick way that you can do that is take the features that you want to move at once, and then right click and add to folder. And then don't even name the folder because you're going to throw it away anyway. But now that you have it folderized, you can actually just drag that up. And now it's and then delete the folder. And now you've moved all of those at once. So this is a pretty short tree, but imagine long trees. This is really, really useful to do. And it's probably, I'm going to get into another tip in organization of your feature tree where you're folderizing. This really becomes a valuable feature. I work with a lot of industrial designers in my business, and a lot of times it's about change and refinement of the models. And one thing I run into often is industrial designers like a lot or all of their surfaces to be continuous. That is, instead of using fillets, they want to use C2 fillets or splines to make everything nice and smooth. And for you that are working in the consumer product design industry, you know this. So one thing I like to educate the industrial designers on is that oftentimes it's not necessary to have it C2, but there's ways to do robust modeling and still have C2, but also have robust features and editable features. So one of the things that I do is oftentimes I will introduce them to Conics, which are a way of getting C2, not technically, but it gives you basically the same effect. And so in this example, he has a through point spline with C2 with curve continuous assigned to either end. But we know that curves like this, they're very hard to fully define. I mean, you could dimension both the magnitude endpoints with a value, and even create a relationship between those two if you want them to be the same. But it's a lot of work, and they're a little bit finicky. There's not a real value there. So instead, what I do is I ask them, well, let me use a conic. So a conic is a very useful piece of geometry in Sketch because it's defined by a beginning and end point and then a row value. And oftentimes you can get the same result that you can with a spline. So The reason there's a little bit of bug here, and that's with the solver, but no worries, it'll go away. As soon as we replace these two, let me do that really quickly and then we can get through this. So I'm going to replace this with the conic and then assign my row value. And put something in there like 0.575. And now I can dimension it. And dimension my vertical. But I think it's because I already have that constrained, so I'm going to not do that. And so now I have something that is very C2-like, but I have more control because I'm using a conic. And you get the same result where you get this gradually fading radius into its vertical and horizontal face. This next tip has to do with how can I make my features work better. And one of the tools in my arsenal to make that work, especially for swept features, is to oftentimes try using a Fit Spline to rectify issues like what you see right here. So this is a gasket that kind of sweeps around a 3D form, and you can see the sweep is not resolving correctly here on this on the sweep geometry. So if we show the sweep, we have this 3D sketch, and it's made up of a number of splines and arcs, and it just doesn't work very well for this shape. I know, though, after using this, using sweeps, that if you can help the sweep to resolve the path and make it more simple, it's likely that the sweep's going to work a lot better. So what I'm going to do here, instead of having all this separate 3D geometry, I'm going to leave it in place. I'm just going to box select it, and then S key to Fit Spline, and I'm going to fit a spline over it. And this now, by doing that fence select, I've selected other parts of it that don't really want to work as a Fit Spline. So what I'm going to do is right click here and select chain. And so now when I do a Fit Spline, I get my combs. I can change the tolerance of this. I can make it a little tighter. And when I accept that as a constrained Fit Spline over the original geometry, I get a single entity. So because I have a single entity, I can rebuild, and you can see I get a much nicer result on my on my spline. Another thing I want to do, and this probably is getting off topic a bit, but I really want this gasket to sit flat along its perimeter. Right now it's just kind of a general solution. So I'm going to edit my sweep, and instead of using minimum twist, I'm going to use specify direction vector. And so what this does is if I pick this axis on the Y, it's going to take, and the sketch or the profile that sweeps is always going to recognize that vector and sweep the profile normal, or I don't know how to say it, tangent to this vector. So when I rebuild the feature, I get more of what I want. And that is, I want the gasket to kind of lie flat here, I want it to lie flat here, and I want it to lie flat here. So that's how you can use the option direction vector, and also use Fit Spline. Another use for Fit Spline that I can think of is when it comes to cams. Cams like to work between a cam and a cam follower in having a tangent relationship by seeing a single entity. If you're building components in an assembly and then using the cam mate, the cam mate is usually smart enough to be able to figure it out even if you have multiple entities making up the profile of the cam or the follower. So I wouldn't worry too much about that, but sometimes I like to experiment down at the sketch level with blocks and see how these are going to play out as I develop my design. So here I have a block, and if I go in and edit this sketch, I've got a block of this cam, and then I have a follower. But as you can see, I've really only made a tangent relationship to that single arced entity of the cam, and it's not really going to work the way that I intended it. So a way to get around that is if we take a look at our solution. Let me just go ahead and unsuppress that. With this sketch and its block, I'm going to edit the block. We have our original geometry here. I'm going to just reapply this. So I'm going to pick the chain and I'm going to apply a fit spline to it. And now we have a single entity, and I'm going to exit the block. And let me just reapply that tangent mate just to be sure. And I think we want to do it up towards this part here, where these two smaller radiuses are. So let's do the tangent mate there, and let's see what happens now. So now what we have is a single spline entity that has the ability to follow the cam because we've used a fit spline through that geometry. So that's a way of getting a little better interaction in your sketch blocks using fit spline. Now with this tip, I'm going to show you how you can use spline geometry more intuitively. And a lot of you know of the Thru point splines, been in SolidWorks forever. And then we have the style spline that came in I think 2014. And it's a higher quality spline that has better internal continuity, and you might already experienced using it. Unfortunately, for a lot of users, it's a lot harder to use because it's based on. Let me just edit this sketch in the front view, and let's start a style spline. So with a style spline, you're using a cage to set out a number of control vertices. And as you do that, you're just kind of approximating where that spline's going to lie. And for a lot of users, this can be rather difficult because you're really not, trying to you're really not aligning it to where you want it to be aligned. And so once you've placed it, you have to start manipulating it to get it to where you want it to be. For a lot of industrial designers, this is a very natural thing to do. But for a lot of engineers, it's really a pain. So the SolidWorks product definition people knew this, and what they did is later introduced in later versions the ability to use a through point spline, which we are all used to, and convert it to a style spline. So now I'm laying down a through point spline and following this rather accurately, probably putting in more points than I really should, but nonetheless getting a better first definition of the curve that I want to follow, and then ending there. So now that I have that through point spline, if you right click on it, you can go to the command convert to style spline. And once you do that, now it converts it to a style spline that's much closer to your design intent than trying to do it from an original style spline. And then from this point forward, then you can start to do finer manipulation and get it to where you want it. Now you might ask, why not just use a through-point spline and not use the style spline? Well, I'll get into that in a later episode. Maybe I could just undo a couple versions here. This is back to the style spline. If I turn on the curvature display, through-point splines have a harder time maintaining internal curvature, and you can see that right here with this point, especially when you start to manipulate their points, then it becomes very hard to control them and get a more smooth result. Versus the style spline, if I can go forward, actually I can't, I need to go backwards. Let's see if we can do this. Yeah, so with a style spline, we show its curvature comb, it's much, much smoother. And if you start to add more vertice points, polynomials, and let me do that right here. So the way you do that is right click, insert sketch control point, either on the cage or this original spline geometry. If it has a little circle with the slash through it, means that you cannot place that point there, but I can right here. And you can see how it does a much better job of maintaining internal curvature because it is just a single B-spline. And so it's a better curvature solution than what you saw before. So that kind of answers your question, why would you want to do this? But hopefully the point is that you can lay down a through-point spline and then convert it to a style spline and have the quality that you need. In this next tip, I want to highlight a recent feature that came into SolidWorks, not actually recent, I think probably 215, 216 maybe, maybe earlier, of a feature that caught me by surprise, and my colleagues pointed it out to me, and when I discovered it, I was just elated because it's a feature that I've wanted in SolidWorks for a very long time, and that's the ability to delete features without deleting their children. For a very long time that was not possible. It is possible now to do that, and it's kind of a hidden feature, and that's why I didn't notice it, but let me walk you through that. So here we have this half a gearbox housing, and for whatever reason we have to change the base feature to another feature. We can't, so the designer wants a crown going through this area, and we can't take this current feature and kind of modify it some way so it's still the base feature and everything regenerates on top of it. So, so what we have to do is we have to delete it. And we know when we start deleting things way up in the tree, all kinds of bad things start to happen, because you can see how many references, children references, are related to this base feature, almost all of them. So when we hit our delete key, what we see is one fillet feature and not much more. But if you click on this advance button, now you get to see the real picture. And below here we have all of the children features. And usually what happens is when you're first entering this dialog, you have delete absorb features or delete child features, or both. And if you hit advance, you're going to see everything that's deleted or is going to be deleted. So fortunately now we have the ability to not delete those and delete the current feature. So I'm going to uncheck both of those and say yes. And now you can see that I'm still rolled back to that sketch. Nothing's rebuilt yet. And what I'm going to do now is change the design intent of my base feature. I'm going to go into the sketch, and you can see I have a construction line down here for revolve. I'm going to go ahead and revolve this part. But instead of just revolve it 360, I'm going to revolve it up to this surface. And then in my second direction, I'm going to revolve it up to this plane, or I said surface before, actual plane. And then once I have that, I'm going to use this top plane to cut the bottom to make it flat. So now I have something very similar to that last feature that I deleted. And I have an entirely new definition on the surround. So unfortunately, it's not the magic that we all want, and that is that everything, all the children on top of that are smart enough to regenerate and fully define without any errors. That doesn't happen. What you do get is something that looks like this. But it's just a matter now of going through and just repairing the dangling dimensions. Because as you can see, I haven't lost my features. I've only lost dangling sketches for the most part. And that's a lot better off than having all those features deleted and having to rebuild and from scratch each of those features. Now I can just go in and repair these sketch dimensions and dangling dimensions, and I've gotten through it much faster than if I had just deleted it with its children. In this next tip, I'm going to talk a little bit more about selection using some of the things that I've already shown you, and maybe going just a bit further with selection. So with a lot of the features that we have in SolidWorks, we have the ability to do some pretty smart selection. One of the selection features that is there in almost all features is select other. So if we're in a feature or a sketch and you see this button select other, the way that works is that it allows you to pick the very next face of where your actual mouse cursor is sitting right here. So this is the face opposing that rib that I'm looking at. If I keep traversing down the list of faces that are selectable here, I just keep going further and further into the model. So you can see I'm picking all these back faces until I get to the very end where there isn't anything else I can pick. That's very useful because a lot of times I don't want to zoom out, rotate, and then pick something. I want to just get to it very quickly. Like for instance, right here, this interior boss, I can see immediately I need to work on to change that because it's not going to work as a tap for a screw. And I'm using select other to see that. So that's using select other. Let me talk a little bit more about lasso select. This is a vacuum cleaner housing. It's got a lot of bosses in it that I'm going to change or don't need and I want to change. Again, if just to highlight the lasso select here, if we want to delete those faces, we can come in outside the model, come around the boss that we want to delete, leaving the ribs, and then just delete it. And the method there of coming from outside the model and then into and out, that's a form of selection, because if I were to just use a rectangle select and use delete face, wherever I touch down is going to be selected automatically by the box select or fence select. So that's why I'm using the lasso select and starting outside and then finishing outside. A lot of the other features have built into them pick tangency, pick open loop. Say for instance down here we want to just remove this pocket and we want to do it with replace face. There's a fast way of doing that. I'm going to create a reference face here by making a surface copy, which as we know is offset by 0. And then with that current selection or the last selected command, I'm going to go right into my replace face. You can see it's already populated the reference surface. And then down here, I'm going to, instead of picking all these individually, I'm just going to pick select tangent. And now I have my selection except for this face, which is my reference. And then I can complete my command. And now I've quickly made that change with using the tangent select. Let me turn on my display tangent edges, and let's roll into the solution here where I can show you a little bit more about how selection works in features. So if we're at this point where we have a hole that we need to patch, and so here's a hole that we need to patch with the fill surface, very useful command I'll get to in a later episode. We could just start picking edges of that hole, and that'll work, except for you run the risk of mispicking like I just did the face. I didn't really pick the face, but it's just really tedious, right? So what often happens is when you're filling an open boundary. And so if you right-click one of the edges and pick Select Open Loop, it automatically populates that open loop. And many times I'm using fill surface, I'm actually have this kind of condition where I can do this. I'm going to turn off optimize surface. I'm going to apply tangency to all the edges. And now very quickly I've created my fill. Oh yeah, I forgot to merge and then make solid. So that's a way of using some of the selection features inside the feature.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to excel using SolidWorks day to day. You'll see below some links to example models used in today's video. Feel free to download them and explore these techniques at your own leisure. Also, we'd love to hear from you. Please email me at the address you see here. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.